Good afternoon, everyone. My name is Gilbert Nicholin, and this is my partner, Stawin Revano. I'll be presenting about our work about prompting strategy versus model selection, a comparative study of open source LLMs for fake news detection. Next. So here how we talk the structure. I start with the motivation and the gap we address. What through our experimental setup, present result, and the last is the closing. Next is about background and motivation. So, fake news spread rapidly on social media and cause real social harm, distorted public perception, eroded institution trust, and deter politicization. The sheer follow of daily content makes manual fact-checking impartial, so automatically detection is essential. Traditional approach relies on fine-tuned transformers models, which work well but needs large amount of label data. Recently, introduction following large language model have opened a new paradigm, classify text simple through prompting without any task-specific training. Next, research gap and question. Most exciting brands marks either test commercial models like GPT-4 or test open source models only with zero-shot prompting. This leaves an open question for the last generation of open source LLMs. Does performance depend more on model choice or on prompting strategy? That's the central question our study answer. Next, methodology dataset. So we use the VEL fake data set with merged for independent news source, reducing the source leakage bias that affect single source dataset like AOST. After cleaning, we draw a balanced stratified sample of 2,000 articles for evaluation, with a fixed random set for reproducibility. 6 additional articles were set aside purely for the suit examples, keep completely separate from the evaluation set to prevent data leakage. Next, methodology models. So we select 3 open source models released in 2024, Mistral 7B, Llama 3 8B, and P3.5 mini. The smallest of the three at under 4 billion parameters. All models were run locally through Olama using 4-bit quantization on a consumer Grand RTX 4050 CPU with temperature set to 0 for determines reproduce output. No fine-tuning was applied. We want to isolate the model inherent detection ability and set purely by prompting.
Alright, so the next one is methodology prompting strategies. So each model was tested under 3 different prompting strategies. First one being zero shot. Zero shot gives only the article and also the classification instruction. And then the next one is few shot, which adds 6 label examples, 3 real and 3 fake one, which is drawn from outside the evaluation set. Instruction tune prompting replaces example with explicit list of linguistic signals associated with real and real versus fake news. And every prompt forces the model to answer with exactly one word, real or fake. So it gives us 9 model strategy combination in total. Next one is evaluation metrics. In this case, we use 3 different metrics. The first one being accuracy, and then macro F1, which prevent class imbalance from hiding asymmetric errors, and also outro. And here's all the 9 results. Three clear patterns emerge from this result. First one being Pi 3.5 mini performs strongly and consistently across every strategies. Llama 3.8b, on the other hand, swings dramatically, modest under zero shot and insertion shoot, while jumping to match Pi best scores under few shot. And last one being Mr. 7b, which underperformed across all the board, barely moving regardless of the prompting strategies. And then this is the heat map and also the confusion matrix. The heat map visualizes this very clearly. 5 minutes stays uniformly dark across all strategies. Llama 8b has one very dark spot at few shot, I mean. And Mr. 7b stays uniformly light across all tests. The confusion matrix tells us why. Pi 3.5 mini takes both class in a balanced way. Mr. 7b, in contrast, show a strong and persistent bias toward predicting real, regardless to the actual content, correctly catching nearly all real articles but missing the majority of the fake ones. This bias appears in all three prompting strategies, telling us it is its fundamental model characteristic and not a prompting problem. And then we wonder, why does the smallest model perform the best? And because of that, we compare public training documentation across all three. Microsoft explicitly trained Pi 3.5 mini with truthfulness and reasoning as a core objectives. Properties, which is a properties that map directly onto fake news detection. On the other hand, Llama 3 and Mistral don't share this explicit focus, and Mistral disclosed almost nothing about its training data at all. This relationship is correlational, not proven causal, but it's a more good explanation than parameter count alone. So for the conclusion, uh, model selection has a stronger effect on detection performance than prompting strategies. Pi 3.5 mini is our recommended default for open source deployment. It's small, fast, and consistently accurate. Llama 8b is a strong alternative, but only if you invest in few short examples. On the other hand, Mr. 7b is not recommended for balanced detection without further calibration. Going forward, we'd like to extend this to larger models, multilingual data, and out-of-distribution news content. So that's the presentation for our research paper. Thank you for watching.